Hi guys, how are you today? We're starting section 5.5, which is the law of sines, and this is a very important section as I discussed with you before. I really don't want you to leave my class without knowing what's a law of sine and what's a law of cosine. As for law of sine, you might ask, what is it used for? Well, law of sine and law of cosine are used to find missing sides or angle in any triangle. As you guys know, in geometry class, you used to find angles, you used to find sides in a right triangle using trig ratios. But now it's not a right triangle, it's any triangle. So the ratio would be sine A over A equals sine B over B equals sine C over C. What does that mean? Whenever we say sine, it has to be sine of an angle. So if you label angle A, side lowercase a has to be the side opposite of it. This is a very important. Labeling the triangle is the most important part of the problem. Label angle B, that means B lowercase is the side opposite to that angle, and so on. So this gives you the ratio of law of sine, and if you flip it over, it will still be true. It will still be correct. So it depends on how you want to use it. Both are the same. And again, lowercase ABC are sides, uppercase ABC are angles. So let's take a look, and why and when do we use this? We use the law of cosine. It's useful for solving triangles, which means finding missing sides and angle in any triangle, and that's what makes it different from what you have learned before. I know some students, when they took the acuplacer, they came and asked me, oh, we had a missing side in a triangle, but it wasn't right triangle, so what should I do? This is what we're going to do using the law of sine or law of cosine. When do we use the law of sine? If the triangle is an AAS, which means angle, angle, side, and I'll explain that in the examples in a minute. And the next one, ASA, angle, side, angle. You guys use this terminology, I would say, when you did congruent triangles. But this is a little bit different. We don't have two triangles and we're comparing them. We have one triangle and we want to see what's given. Am I given two angles and a side? That means I'm going to use the law of sine. Am I given a side and two angles where the side is between the two given angles? Then I'm going to use the law of sine. And we'll see that we'll clarify this in the example. So this is example 1. Solving a triangle given two angles and a side. I have a triangle ABC and I have to draw this triangle. I have angle A, angle B, and lowercase a, which means the side A. So I draw the triangle, and some of you might ask, where should I put the ABC? It doesn't matter. The vertices could go anywhere. Now you're going to see I use this as a standard. I start with A and the lower left corner, then I go B and C. It's just, a comfortable way of drawing it, but doesn't mean you can't move the vertices. The only thing, if you move the vertices, you have to make sure your lowercase a side is facing the angle A, wherever the angle A is. So I draw the triangle, I label ABC, I put the 36 degree because it's given, and I put angle B. And right away, you guys know that we can find angle C because 180 minus the other two angles will give you the third one. And that's not nice to find right away because, again, the question is solve the triangle, which means find the missing sides and missing angles. So by the end of the problem, you should have all three angles either given or found, and all three sides either given or found. So the 6 parts of the triangle should be cleared up by the end of the problem. So then I put side A facing angle A, so that's 8. And I can't use Pythagorean because it's not a right triangle. I can't use inverse sine, inverse cosine, inverse tan again because it's not a right triangle. So I have to use, and it's my only resort to use the law of sine. Now, this is a ratio of 3 fractions, which means I can use these two together. or I can use these two together, or I can use the first with the last. That was a common misconception last year. You could use any two together. So I see what I have. I set it up, and then I have angle A, and I have side A. I have angle B, but I'm missing side B. So I can't take those two fractions together because I have two unknowns in them. Then I'll take the first with this. So I can recopy it, just taking the first two parts of that ratio, and then cross multiply, or if you want, multiply each side by sine of 36. You can give it any approach you want from here to here. I like cross multiplying. I cross multiply, then I divide by sine of 36 degrees, and I put it in the calculator, and I get side B. And then I still need side C. So what I do is I can take now either those two, because I got side B, or I can take the first with the last. And I would prefer not to go back to something you found. Like, for example, I just found side B. Well, if I made a mistake, I don't want to take this. I'd rather take something given with what I need to find, if that makes sense. And that's what I did, I think in the second, the image. So I took the given with the last term of the ratio. And again, I cross multiplied, then I divided by sine of 36. I did that in one step because this is pretty basic. And then I got 13.54. Just make sure your calculator is on degree, because the angles given are on degree. So now I have, let me check. I have all the 6 parts, and I want you, I don't think I did that in here, but I want you at the end of each problem to list all 6 parts of the triangle again. So all 6 parts of, I'm going to do it orally. All 6 parts of the triangle are angle A 36, angle B 48, angle C 96, side A 8, side B, which is 10.11,